Hi folks, this is Chuck Black. We are doing 52 weeks of Python. We are in week number 9, and this week we will be looking at Python comparisons. That will be seeing if two things are equal, less than, in, things of that nature. And most of the time, in fact all of the time of the class is going to be consumed by the code that we go over in the examples that we run. So I'm not going to be spending a bunch of time on Quokka stuff, but I figured before we began, I'd show you a little bit about the thing that I did recently add. I added an Nmap extended scan that you can see displayed here on the screen. This is the output of Nmap. You can point at any host. You can see over here on the left, there's the host table. I pointed at a host on one of these buttons here, and it went out and did an Nmap scan of that device. Now the device that it looked at is my router on my home, and it looked and it showed me, it discovered what the IP address was, what the MAC address was. It has a host name. It has determined that the OS class is Linux. So this gateway that is running that I got from my internet service provider is actually running Linux as its base, as most networking devices or many networking devices are these days. When you go down here, it shows you the ports that are getting used, that are open. Port 53, of course, that would be DNS. Port 80 for doing HTTP. Port 111, which seems to be this RPC bind. I'm not familiar with exactly what it does. And port 443. So you can see this is an extended port scan that we can do on these hosts. You do it by clicking on this particular icon for the hosts. I see that I still haven't fixed the tooltip, so that's readable even on my screen. Putting my nose right up close to it, I can barely read it. So I will get after fixing that in the next few weeks for sure. But yeah, this is just pretty much everything is the same as it was. When we look at devices, you can see the response time of the device and the CPU utilization, which is pretty low. I can go and look at OS compliance as well as configuration compliance, something that I'm still a little bit working on. I just automatically discover hosts, and you can do packet capture, which we talked about a while before. You can do a simple open TCP port scan as well as an extended port scan for services. We can still do things like look at both the availability and response time for services, and I'm keeping this information over time so that every hour I record what the response time was, and I have this SLA line that helps me to know if it's meeting what my arbitrarily assigned SLAs are. I do have an event log, so like if I was interested in saying, okay, well, these availability things are interesting, but are there any SLA violations? And I can see, oh yeah, I've got a few SLA violations. That's kind of nice. And if I would done packet capture, stuff would show up here. Anyway, this is Quokka. Right now, though, we're going to talk about comparisons in Python. So without further ado, let's start with that lesson. Okay, so in this lesson, we are going to talk about comparisons. We're in this one over here, L6, comparisons. What are comparisons? Well, in Python, comparisons are just things like comparing if two things are equal. Hopefully it will be fairly self-evident what's going on. For example, here I'm looking at my devices and figuring out, is this device a Cisco device? If I go down here, you can look and see, here's another different type of comparison. I'm saying, is the vendor OS in this thing that I've created called standard versions? That's because I want to go down here later on and I'm going to compare to see if a particular device's version is what we have stored in standard versions. I'll be going through all of these one at a time. Here's other examples where comparisons are just equals. We use the double equal sign. Here's some comparisons where I'm looking at availability and response time, and we use the less than for availability. That would indicate a problem, and then greater than for response time. That's what we're talking about when we talk about comparisons. So I've written a bunch of code to do some examples. Let's go ahead and run this and see what happens. Here's my output. Let's start at the very top. You can see the first thing that I'm doing here. You've probably seen this before. I've created a bunch of devices and I've printed them out in a nice table. So let's look at the code that accomplishes that. It's right here at the beginning. Now remember, we've gone over this before. I'm calling this thing called create devices. Do you see how nice it is that it highlighted in my code here, create devices? It also highlighted other examples of where create devices exist. And it actually gives me a little bit of helpful stuff, as you can see below in this box about that. So what I've done is I've created something called create devices. It's in my util package in the module called create utils. If you recall, if you're using PyCharm, I can just do Control B and it'll take me directly to that particular piece of code. And here, that's more information than I want to see, the thing that popped up. This is just a function that's going to create a set of devices. And if you recall, I'm randomly creating a number of things. Here I'm using the random choice module. You can see it's highlighted all throughout this. I'm choosing the version, the vendor, the version, the operating system, etc., and returning the devices depending on how many I've requested. And you can see also I can quickly go back to where I called it from. Let's see, so I go back and here I am where I called create devices. And so I'm passing in, I want 2 subnets and I want 25 devices. Remember, when we call functions in Python, we can pass these parameters positionally, in which case I would not have this keyword with the equal sign next to it. Sometimes it's a lot easier to read. If I had just put 2, 25, I would have had to know that the first parameter I was passing was the number of subnets and the second one was the number of devices. But here I have actually specified that. It makes it a little bit more readable. So I've created all these devices. As we look over here, you can kind of look at the IP address 10.1.1, 10.0.1.1, all the way up to 10.0.1.25. And then I go to the next subnet. Remember, I'm just using simple subnet masks. And so in this situation, I have 10.0.2.1 all the way up to 25. So I have all of these devices that I've created. Remember, the names are random. The actual, for every vendor and OS, I'm randomly choosing those, and the version number, I'm choosing those randomly. This is going to help when I give you examples of comparison. Now, in the real world situation, if you are a network engineer or network administrator, of course, these are going to be real. The devices, they'll have device names that are real, vendor OS that are real, version number that's real, etc. But you're going to want to be doing some of the same things that I'm doing. And so that's why we've got the code here. So this is my code that actually goes through the list of devices that it's been created and just prints them out. Remember, this is just a regular print statement, and I'm using an F string. An F string is a special type of string in Python where I can put actual data into the text of the string. So everything in these curly braces is actually a variable that I'm going to print out. The variable I'm printing out here is the device name. When you look at it and you see something that has device and then square brackets with a key inside, then that tells you, okay, well, this is a dictionary. I know that. And then the last part on the right hand side of the colon, that is telling me how many characters to print. That's the 7. And then this little greater than sign is actually, it's not doing a comparison. It's just shorthand for saying, please write justify this. For vendor, that's write justified. Here's some actual text that's getting printed out. Space, colon, space. If we look at the output here, you can see space, colon, space between the vendor and the operating system. So this is actual data. And then once again, once I get inside my curly braces, this is a variable that it's printing out. That's the operating system. As I go a little bit further, I can see my device IP address and then the device version. And so I've put the spaces in here appropriate to allow it to print according to this information that I've got right here, this header. And so I had to play with that. Now I've done that, but we're talking about comparisons. That's been a quick review of printing and of functions and packages and stuff. But what we want to do here is do some comparisons. So if I wanted to print only the Cisco devices, then what would I do? Well, one thing I can do is I've modified this right here. You'll notice this is exactly the same. The only difference is I've put in this if statement. And this if statement in Python is saying if the device vendor is equal to Cisco. Now I've also put .lower. This allows me to do a case insensitive comparison. It's going to take the device vendor. If the vendor happened to be, you can see it's all lowercase here, but if I happen to have a capital C for Cisco, or maybe there was a typo where I had a capital I or S or something like that, or maybe it was all caps, this allows me to do the comparison based on, I know that I can put this here. This is going to be all lowercase over here. So I'm just going to force whatever device value that is to be lowercase. And so it's doing that comparison. Now, other languages, if you're familiar with languages like C, C++, Java, they have comparison functions that actually say compare but ignore the case. Python does not have that, so you need to do .lower. And then it prints out. So if I scroll down, here's the second instance, and you can see this is printed out. Whoops, let me just make sure I highlight the right stuff. Every one of these devices is Cisco. If I wanted to, and I decided, you know what, I don't like Cisco, so I want you to eradicate all instances of Cisco, then we would get something that looks like this. I'll scroll back up, and here's my first list where I list everybody. You can see I have Cisco, Juniper, and Arista. Here's the second list, and you can see I only have Arista and Juniper. I did not print Cisco devices out there. So there we go. That is a simple comparison, a simple if statement. Now, simple Python stuff, you'll notice whenever we're going to do a code block, remember we put a colon and then we indent the next couple lines. So that's just basic Python 101, how you do code blocks. Just like we do for loops, we've got the same thing going on there. Now, the next thing that I'm going to do is I'm going to actually compare device names. Now, this may be useful if you're comparing IP addresses to see if there's a duplicate IP address. You could also do what I'm doing here, which is comparing for duplicate names. Now, remember, when I created this stuff, here's where I create the devices. What I'm doing is I'm just creating the device name made out of R2, R3, R4, R6, or R10. Those are actually buildings where I work in my real life in the networking division at HP. And then I add L or U, and then I add just a string of ASCII letters, and then that becomes my actual device name. And this is what I end up here in my actual names. You can see that I've got these names here. Now, there's nothing to guarantee that I'm not going to end up with duplicate names. And so I said to myself when I started to do this, hey, why don't I just go through and see if there are any duplicates? When I scroll down here to the output, you can see in this situation, I found one match. The device name R10LC is used both for 10.1.16 and 10.2.13. If I scroll up here, and I can remember this, 10.1.16 and 2.13. So 1.16, you can see that has that. And the other one was 2.13. And lo and behold, R10LC, that's the name that we found that was a match. Now I'm just going to run this again so you can see, since I am creating all of this randomly, then you can see, okay, well, this time I found two matches, and these are actually different names, and they're different devices that ended up being matches. That's because I'm generating the names randomly. There theoretically could be a situation where there were no matches. There could theoretically, every name could match, although that's very unlikely. So just the randomness of how I'm creating these device names. So how did I do that? Well, this is going to be a little bit more complicated, so I want you to bear with me as we do this. I'm going to start, here's my list of all the devices. And here is the loop where I'm comparing to see if there's a match. Now, the first thing that I do is I'm going to have a for loop, and my for loop is going to go through all devices. But instead of just going through the devices, I actually am interested not only in the device itself, but also in the index. In other words, this is the first one, this is the second one, this is the third one, this is the fourth one. Bear with me, I'll explain to you in a moment why that's important. And the reason that's important is that we are doing a for loop within a for loop. So here you see my second for loop. So the first for loop is going to go through these devices one at a time. So we start with this device right here. Now the next for loop is going to actually go beginning at my list of devices where I currently am. That's the index. Remember, I got index from the enumerate function that I called. I'm going to start at my devices list at the current index that I'm at plus 1. That means my second loop is going to go from here all the way down to the end. And so I'm going to have one device here. I'm calling that device A. And then I'm going to have device B be pointing first here, then there, then there, then there. And I'm going to go through these. And for every time I do go to a new device B, I'm going to compare the name of my original one, that's device A, that was this R6UO up here, and I'm going to compare it with device B. So first I'll be comparing it against this one, then this one, then this one. When I'm done with going through all of these, in other words, this inner for loop, I'm going to go back and go to the next one up here in the outer loop. So now device A is pointing, if I can highlight this correctly, it's starting at the second one. And now my inner for loop, stick with me here, I'm starting at devices index plus 1. What is index? Well, the index is actually this second item here. So it's going to start, now my inner loop goes from here all the way down to the bottom. And eventually I will be going through and not doing comparisons of the previous ones that I've already done. When I'm down here, let's say, when I'm down at this, then my inner loop, device B, only goes from here, see if I can do this correctly, down to the bottom. And now I'm just comparing for every one, I'm comparing just to see if the name matches. And if it matches, here's my F loop. Let me make this a little bit easier to see. I'm going to print out, I found a match. I'm going to print out, remember this is my data, device A subname or key name. That's the name that it found that's the same. And now I'm going to say it's the same for both IP address at device A and the IP address at device B. So let's go and check that really quick. What did I find this time? R6UO for both 10.0.1.1 and the same as for 10.0.2.12. So let's go up here to the top. 10.0.1.1, sorry about that, was the same as, and now because I misspoke, it's the same as 2.12. So let's go back up here and look at 2.12. Hey, R6U0 is the same as R6U0 there. So sure enough, my output is correct. R6U0 is the name for both 10.0.1.1 and 10.0.2.12. Okay, so now let's move on to the next thing that I'm going to do. Now the next thing in terms of the code actually is all of this code right here. And what I'm doing, let's just take a peek ahead. I'm actually creating a table of arbitrary standard versions, and then I'm going to compare down here to see if any of my devices, my randomly created devices, doesn't have that same version. And let's look at the output again, just to understand what I'm going to do. I'm going to first have a loop where I go through all of my devices. And again, because things are random, this is going to vary depending on when I run it. And I'm going to say, okay, well, for Arista, EOS, this is my arbitrarily chosen standard version. And for Cisco iOS, this is my randomly chosen standard version. And for iOS XE, iOS XR, Nexus, and then for Junos, the same thing. So the first thing that I do, this first loop right here, is I'm going to create standard versions. And like I say, I'm going to arbitrarily choose the first version that I find of all of the devices that I've just created. So Arista EOS, I chose 4.23.2F. If I go to Arista EOS 4.23, I chose that one. And I said, okay, arbitrarily, I'm going to say that is my standard version for that vendor / or vendor : operating system. You see, it gets more interesting with Cisco because you have all these different operating systems. So I have different versions chosen for each one. So once I've created this list of arbitrarily chosen standard versions, what I'm going to do is I'm going to come down here and I'm going to compare every single device and see if it matches this standard version that I've saved right here. This is standard versions. It's a dictionary. What I've done is I've created this thing called vendor OS, which is a concatenation of the device vendor and a colon and the device OS. And so for every one of those, I've got, as you saw here, I've got a version number. So what I'm going to do is I'm going to go through for each one of these. The first thing that I'm going to do is I'm going to initialize an empty list of devices that are non-compliant. This is my non-compliant devices. So I'm going to go through my standard versions.items and I'm going to create an empty list. It occurs to me right now that as I go through here, I could have probably done this up here, but I kept it, the standard version, separate from this initialized list. So this is really what I'm doing is I'm creating dictionary just like I have up above. Here's my dictionary up above, but instead of just having the version number, what I'm going to have is it's going to have a list of devices that don't comply. And so now this is where the rubber meets the road. I'm going to go through every single device, and for every single device I'm going to do this comparison between device version and the standard version. And if it's not equal, then I'm going to actually add this information about the inequality to the empty list that I've created before. So I'm basically adding this information. I'm appending this string, which is going to be a concatenation of the device IP address and the version text right here, as well as the actual device. I could have used an F string to do this, it occurs to me, but I'm showing you how to do strings kind of by hand in this situation. One thing I'm realizing is I glossed over the beginning part of this. This is my comparison. So I'm looking at my devices, and what I'm saying is if this vendor OS that I've created is not in standard versions. Remember, standard versions is a dictionary, and a dictionary consists of what? That's correct. It consists of keys and values. So there's a key, and that basically points to a value. And the way that I can say, is this key in the standard versions dictionary, is I say in, or in this situation, I'm saying if it's not in. So let me go through here, spend a little bit more time on this creation. I'm going to go through every device. I'm going to create this vendor OS, which is just this going to be this string with a colon in between the vendor OS. Then I'm going to take vendor OS and say, is that key in this thing called standard versions? Now, the very first time through, there will be nothing in standard versions. And so this is going to be true. It's not in there. So now I say standard versions, vendor OS, let's say Arista :EOS like we did before. And I'm going to choose the version number to be whatever this arbitrarily first version was. The next time I go through, so basically if I look at Arista EOS, the first time through, I found this one, so I set my standard version to 4.23.2f. Now the next time through this loop over here, I'm going to the next device, and when I look in standard versions and I say, is vendor OS in standard versions? I'm going to find, oh, I've already got something for that, so I'm not going to update it with a new version. So at the end of this, I will have gone through here for every vendor OS pair, and I will have created the standard versions, and that's what you see here. This is my standard versions. First time through, I created Arista EOS, and then every other Arista EOS I ignored. I took the first one and said, okay, I'm going to arbitrarily say that is my standard. Now what I'm doing, this is where the rubber meets the road, going through all of my devices and saying, are you compliant? And in this situation, I'm looking at my device's version and I'm comparing it to the standard version. So when I go through the first Arista EOS device, I'm going to compare the version to this value right here and say, is that a match? And if it isn't, I'm going to add to my non-compliant devices this device information. Now, if we peek ahead here, you can see this is the string that I've added, 10.0.1.4. If we peek back at the data that we had, so that would be this one right here, 10.0.1.4, and you can see the version number actually does not match. And if we look at the output here, you can see I found a bunch of Arista EOS ones, a couple of these Cisco iOS ones. Now you'll notice, why is here I printed out my list, one per line. Here it actually put a list, but it had two per line. Why did I do that? And the answer is, well, look over here on the left, I didn't actually do that. Pretty Print did that for me. And it said, oh, well, this fits on one line quite easily, so I'm just going to put it on one line. So don't let that confuse you. In fact, it happened for both iOS and iOS XE. And remember, these data is randomly generated. If I come back here, let's look at Arista. The first one that failed was 10.0.1.4. I'm going to run this again. And presumably, yeah, see, there's much fewer Arista ones. I'm not even sure if these are probably different standard numbers in your real world situation. Of course, you will have said, hey, this is what I want the version to be. You won't be doing random stuff like I am just for this class. Anyway, that's looking at stuff, whether it's a key is in or not in a dictionary. That's another type of comparison. One other thing that you might be interested in here, I'm putting an underscore. Now in Python, an underscore all by itself can mean different things depending on where you are using it. In this situation, remember, I'm iterating through, oh, let's take a look at this. If I do dot items, that's a good clue. If I need to look back, I can say what type of data structure is this? It's a dictionary. So when I do dot items, that gives me the key and the value. So in this situation, I'm only interested in the key. I don't really care about the value. Now there's ways to get just the keys. I think if you just say dot keys, then you don't need to do this, but I figured I'd throw it in there just so you can see, oh, okay, well, if I want to get items, but I'm not interested in one of them, this is something that you can do. Sometimes we iterate through things and we put this underscore simply because we don't care about the index or the value in this situation or whatever it is. All right, hopefully that makes a little bit of sense. Let's move on to a different topic now, which is the idea of assignment copy and deep copy. So in this next set of code, we're going to be doing comparisons, but sometimes we're going to be wanting to compare not just single discrete items, but like an entire data structure. You may have a dictionary, you may have a dictionary of dictionaries, you might have a dictionary of lists, of dictionaries, of lists, of sets. You can have any arbitrarily deeply nested data structure. And nice thing about Python is you can do comparisons and it will compare all of the data. In other languages, it's way more difficult to do this. You quite often end up comparing just like a pointer to the data structure rather than comparing the actual data itself. Python is very nice in that you can actually compare all the data. This brings up the question about passing data around and making other versions or instances of data available to another piece of the code or to somebody else or something like that. And so we come to this topic of how do you copy or how do you assign one data structure to another in Python? So that's what we're going to talk about here. We're going to talk about assignment, copy, which is actually a shallow copy, and deep copy, which copies the entire data structure. That, in other words, if you have a dictionary of lists, it will copy the entire thing. Now, what I'm going to do here, the first thing that we're doing is I'm saying this is my devices that we've used before. Remember this list of devices right there? We're going to be using that, and then what we're saying is I want devices 2 to be equal to devices. Now, this isn't equals. A 1 equals sign is an assignment operator. So you're used to saying equals, and if you're just telling somebody how to write something, then you can just say equals because that's the equal sign, but this is really assignment. Other languages actually decided not to use equal sign for assignment, but Python does use equals for assignment. What that means is that devices 2 points at the data structure that is located in devices. Now we're going to look at everything being an object, mutability, immutability, etc. later on, but just trust me in this. This means that devices 2 points at the data structure that is pointed at itself by devices. Now what happens if I come in here and say devices sub 0, that would be the first device. The name for that device, I'm going to set it to some value that's not actually one of my randomly generated names. And the next thing that I'm going to do here is I'm going to say if devices 2 is equal to devices. Now I've just told you that what this does is it goes through and it compares all of the data. And because devices 2 actually points at devices, this is actually going to be equal. And so if I scroll down here, we'll see that assignment and modification devices 2 still equals or points to devices. Here's my equals. So devices 2 is still equals to it. And the moral of the story is assignment is not the same as copy. So when I said this, you in your non-Pythonic mind might have said, oh, well, I just take devices, make a brand new copy of it, and then I have devices 2 point at that new copy. That is not what happens. What happens is devices 2 points at devices. So that's why these two are still the same. Devices 2 and devices are still the same because I did an assignment, not a copy. Now let's introduce this idea of copy or shallow copy and deep copy. And let's start to do that. So let's say I want to provide a copy of devices to somebody else so they can go and do their own manipulation on it, or another piece of the code where I'm going to be manipulating that. So I say copy because I just imported copy and I'm going to do a copy. That will give me a complete brand new copy of devices, correct? That is incorrect, okay? So pay careful attention. When you use the copy function, you are going to have happen what is actually a shallow copy. A shallow copy only copies the first layer of stuff. If you have a 5 times 5-way nested data structure, in other words, a dictionary of lists of dictionary of lists of dictionary, then it is only going to make a copy of the very first item, the first level, that first dictionary that I mentioned, and it's going to leave everything else the same. Now, this is useful perhaps when you're doing data science and you're manipulating millions or billions of objects of data. In real world situations that I encounter most of the time, I'm either going to want to do assignment or I'm going to want to copy the entire thing, and this does not do that. This just does a shallow copy. So here in this situation, I'm going to set name again equal my devices 2 name equal to something different. And now I'm going to do this comparison. And guess what? Because I'm beyond that first level, here's the first level, I'm nested deeper than that first level, these two things, devices 2 and devices, are still going to be the same. This is shallow copy. So the moral of the story, let's look over here where I can see copy only does a shallow or first level copy. If I was intending to have my own version of this data that I can manipulate and mess around with, guess what? I just screwed up the original device's data by making this statement right here, this devices 2. So that's not what I probably wanted to do. Now let's do this a third time. I'm going to do a deep copy of devices and call that devices 2. Now I'm going to come in and I'm going to modify my version. And now I say, is devices 2 equal to devices? And the answer finally is no. The deep copy gave me a separate and distinct copy. So device 2 no longer equals devices. And therefore I can do whatever I want with my copy without messing up the original. Now the last thing that I want to point out here is this. I'm going to give myself a completely new set of devices. So I'm going to create the same number of devices, same number of subnets, etc. And I'm going to compare these two. Now, I generated devices using random items random for the name, for the vendor, for the OS. The IP address is fixed in the order that I'm doing it, and for the version. So I generated everything completely randomly. I'm doing this again when I call create devices for this new set of devices. If I ran this 27 billion times, is it possible that my random might end up exactly the same as this? I guess it's possible. I'm not a mathematician. They could probably calculate how many orders of magnitude it would take for these not to be equal. But trust me, it's not going to be equal almost every time that we look at it, probably, definitely every time. So I want to make sure that they're doing a deep comparison of all this data, and sure enough, what should happen is that comparisons of complex deep data is very easy in Python. All I have to do is this, and we see that that works. This is just reiterating really what became evident right here. Here I reached down and I modified one thing down towards the bottom of my data structure, and the comparison ended up working. Now, something else that I want to do is us to look at service level agreement type comparisons, because I want to show you less than, greater than type stuff in a context that will make a little bit of sense. Here I am setting arbitrarily the SLA availability to 96%, the response time to 1 second. These are just numbers. And then I go and I create my devices. Again, I've created my own set of random devices. Now I'm going to iterate through them. And I'm doing a lot of things arbitrarily, but for this device that I'm at, I'm going to assign an availability value somewhere between 94 and 100. And I'm going to assign a response time somewhere in between 0.5 and 1.1. In the real world, these will be real numbers. I'm just doing this to demonstrate comparison. I'm going to look at that device at the availability instant or item that I just created and say, is this less than the stated availability, which, as you can see, is going to be 96. It's going to compare it to that, and if it's less than, then it's going to print this out, and if not, it's not going to print anything. And the same thing for response time. If the response time is too high, then it's going to actually print that out. And if I look at what got printed out, let's see if I can find that down here. Here's my SLAs, and you can see for all of my devices, it kind of randomly ended up, I had a response time that was 1.019, that was greater than 1.0. I had an availability that was 95, that was less than 96. And so I've printed out basically alerts that will go in an event log or something like that for availability and response time. You can see these are kind of randomly generated. I don't know how many I have here, a little bit more than 10, maybe 15. If I run this again, the numbers should actually be different. And so you can see that these numbers are different in the availability versus the standard availability. So greater than, less than, you of course can do greater than or equals, less than equals as well. Now the last thing that I want to do is something that we haven't talked about before. You've used these if you've done any programming whatsoever in the Python world that's more than just the rudimentary stuff. You will have been a user of classes, but you may not have known much about them. And so there's going to be stuff that you do not understand here. Don't worry about that. But basically, I'm creating a class which is a device class because I want to create two devices and then I want to compare to see if they are equal. Now, I mentioned how wonderful comparisons of deep data structures were with Python. You just used equals equals or whatever, and that was great. I wanted to point out that doing this with classes requires some work on your part. If you're brand new to programming and you don't understand Python, don't worry, you can listen to this. You'll pick up little bits and pieces here. You may not understand all of it, but don't worry about that too much. So here I am creating a class called a device with an EQ statement. And you can see down here, I'm going to have a device with no EQ or without an EQ. The EQ that I'm talking about is this thing right here. It's a special thing that you want to create if you want to compare your device with other things. Here's my initialization when I create an object of this class. Then I'm going to set self.name equal to the name that I passed in, the IP address. Those are the only things I'm caring about. And my equivalence comparison is going to basically come through and it's going to say if the name of this device is equal to the one that's getting passed in, that's other, and the IP address of the device is the same as the one that's getting passed in, then I'm going to say it's going to be equal. So it will do this comparison. This will equal true or it will equal false. And you can see this code here. I'm just checking to see that the thing that I'm getting passed in is actually a device, because otherwise I would end up with an exception if somebody tried to do something. So in these situations, I'm going to say D1 is a device with EQ. This is the name, and this is the IP address. And then I'm going to say the one that should be equal is going to be a brand new instance. So this will be a brand new object, completely different. But the values you see, device 1 and 10.10.10.1, those are going to be exactly the same. And now I'm doing a D1, another device. But in this situation, I'm giving it a different name and a different IP address. And I'm going to say if D1 is equal to D1 equal, and it should be, then it's going to print this out, success, these two are equal. And if D1 is equal to D1 different, remember that was device 2, so I'm comparing device 1 to device 2, it should print these out that they were successful. And you can see in these situations, it's printing this out. You don't have to understand all the object language, but it's saying those two, even though they're different objects, these are different Python objects, D1 and D2, but the data within them is equal. So that's why we created this equivalence function, and it's a special function. What Python does is when it sees equals equals, and it looks here and it says, oh, I'm dealing with a class device with EQ, then it's going to go in here and say, hey, did you provide for me one of these? And if it did, it's going to run that. And if it didn't, it's not going to run that. And that's the example right here. This is device without any EQ. You can see I've defined this class. It only has an init function. It doesn't have EQ. And I'm doing basically a similar type thing to what I did before. I have DQ equal and D1. So what I'm going to do this time is I'm going to go through and say, is DQ equal to D1? And I'm going to end up, we'll see down here, I will say it's successful because they're not equal. Remember, there's no equivalence operator. So it's just going to say, is this DQ thing equal to this one? It's not looking at the data. It's just looking at this actual object. It's looking at the object pointer, if you want to be specific, and it's going to say, no, they're not equal. So it's successful in this regard. It's what I expected. They're not equal. And the last thing is, I'm going to say D1 same is equal to D1. That means D1 same, you know this from Python, it's going to point at the actual D1 object. And now I come in and say, is D1 equal to D1 same? Well, it was the same object, so they actually point at the same thing. And so here's my success, there's my success. So we've gone over a whole bunch of stuff related to comparisons. Hopefully this made some sense. It's pretty straightforward. Equals, greater than, less than, in. All of these things allow us to do comparisons of keys in dictionary, of two items, one with another, of integers, of strings, etc.